Hello all. Thank you so much for joining us today, the BIMxt Network. My name is Dana DeFilippi, coming to you from my home office in Virginia. For those of you who do not know me, I'm a BIM technologist at Smith Group, advisor for the Revit DC user group, and speaker at national BIM conferences. 5 user groups along the East Coast have come together to bring you the BIMxt Network. This group is led by a board of advisors to help guide the meeting, and our hope is to provide a live forum for people to share and connect on processes and tools related to building modeling. As a side note, these meetings are recorded and provided online for future reference. On that note, we have a new group on LinkedIn. If you haven't joined already, please join us. We will put up previous meeting recordings and any information from the session that we have to share. The group is also intended to foster conversations and connections among you, the participants. So please ensure you join us on there. If you can't find it, you can definitely get there through my LinkedIn page. So feel free to connect with me as well. Today's topic is a really interesting one. Very excited about it. It's on shared coordinates. We have an incredible lineup of industry experts today, and I know I have a lot of questions. Hope you do as well. First up, we have our very own Nick Sipes, joined today by Marissa Gagne. Hopefully I'm saying that correctly.
Gagne, it's okay.
Gagne, sorry about that. Marissa Gagne. Much more beautiful than I said it. They come to us from CAD Microsystems and will be presenting a recap of their AU presentation, Allies at Last, getting architects and engineers on the same coordinate page. Next up, we'll have Alex Russo. He's actually with me at Smith Group, and he will be talking about basically shared coordinates through his lens as a civil engineer. So very excited to have him and get his perspective. And finally, we have Michael Hurtado. He's a support specialist with Autodesk. Michael will also be giving a version of his AU presentation entitled Coordinating Civil 3D and Revit with Shared Reference Points. After the presentations, we will of course have a discussion where we would like to hear from you, the participants, and of course our audience of experts. So a little bit more about the information here and a little bit about where you can contact our panelists and of course presenters today. Before we get started, I would like to present our randomly selected winner for today. Of course, our winner is our randomly selected survey participant. So congratulations, John Newbegin. You have won a $25 Amazon gift card. Make sure, if you're in the audience today, you look at that email that you're going to get from CAD Microsystems after the fact and fill out that survey. Because if you do, you will be one of the randomly selected winners, and of course could win a $25 gift card. So hopefully you can buy yourself something nice for the holiday. Nothing else. A common response from our survey is the discussion is one of the best things about this presentation. So please use the chat tools within Zoom. Hopefully you can find those. We will do one of these once a month for the foreseeable future, as we have been. And of course, as I mentioned, all of these will be on our LinkedIn group. So please reference that LinkedIn group for this meeting in the future, as well as all of our previous meetings. And of course, as I mentioned, any supporting information. So any websites or slides, anything that you guys may think is pertinent, you can probably find up there. So once again, get out of here. First up today, we have our very own Nick Sipes, joined with Marissa Gagne. Pronounce that correctly?
Yep.
Awesome, yes. And they, once again, are from CAD Microsystems. You guys want to tell us a little bit about yourselves, your backgrounds, and then, of course, jump right into your presentation. That would be wonderful.
All right, Nick, you want to start?
Yeah, so I'm Nick Sipes. I've been in the background of this thing since the beginning of it. In addition to pulling all the levers in the background to make this work, at CAD Microsystems, I'm one of the Revit consultants, specialists, problem solvers, as I like to think of myself. And sorry, I'm trying to do too many things at once.
Nick, of course, helps seamlessly behind the scenes. So as I'm sure he's going back there and trying to ensure everything is working seamlessly, in addition to trying to talk. So
yeah. So anyway, I worked doing commercial interior design for like 10 years before coming to CAD Microsystems. Most of that doing large government projects down to small little tiny office renovations, between Revit, AutoCAD, everything like that. And oddly enough, you think that coordinating with like civil and share coordinates wasn't a big thing. And it wasn't huge for me in that time, but I was kind of the one that was responsible for making all the Revit models talk to each other. So I did end up having to figure all that out. And then fortunately, once I came to CAD Microsystems, we have wonderful people here that have backgrounds in civil engineering, like Marissa, who I will let her talk about her background. If I can ever change the slide. There we go.
Microsystems, as you've heard a couple of times, and I am the practice manager for the civil infrastructure team. I have worked for another number of different companies doing civil engineering, surveying, GIS. I have sort of an eclectic background like that. At CAD, I do a number of trainings, seminar, a lot of different types of consulting projects, and I specialize in mostly Civil 3D, but also AutoCAD, Map 3D, even Land Desktop, which is really old. But I was here basically to work with Nick, and it was a really wonderful thing because, you know, sometimes architects and engineers just don't get along, but Nick and I get along great. So yay.
So that's a really quick synopsis of the two of us. And we kind of teamed up to figure out some of the issues of coordinating between civil engineering and Revit. And one of the things that a lot of people say incorrectly is Revit doesn't understand coordinates. And it's not that it doesn't understand coordinates, it's that most of the time we don't understand what it wants. And the fact is it's a software that's designed to handle not only a building being located in one place, but theoretically you could put that same building in several locations, which that just is really confusing to most people. But the other thing is that people say Revit doesn't understand GIS coordinates, which is mostly true. It doesn't, not without the help of Civil 3D. So you can see on the image here that that's the location panel straight from Revit, and it actually knows a GIS coordinate system code. Most people didn't even know Revit can do that, and it inherently can't. It has to get that data from a Civil 3D file. And so our course, which is like an hour video on AU, basically walks you through about making sure the Civil 3D file is set up to give the data to Revit, make sure the Revit file is set up in order to receive that data. And then once you've got that connection established, being able to send that data anywhere. And I do mean anywhere. It's not just Civil 3D. We talk about getting the data into InfraWorks. We talk about taking that and putting it into Navisworks, because once it's in the same coordinate system, it can talk to anything in that same coordinate system, whether it's Navisworks, point clouds, whatever. And that's the big thing of trying to get your building set up. And so, you know, this course, it required a whole bunch of things. One of the things that we showed in this course, which used BIM 360, was the linking of topography from Civil 3D into Revit, which can only be done using BIM 360. There are other ways to get topography between Civil 3D and BIM 360. You can use Land XML. You can do these things. What's interesting about this is that it natively reads a DWG file straight from Civil 3D and interprets it. And so, and it acts like a link, like any other Revit link. So if it updates, it automatically updates in your model. And we broke it down into steps. The first step is we have to accept a few things. that there are essentially two coordinate systems inside Revit. There's the real world, which Civil lives in, and like point clouds live in and everything like that. And then there's the project world. They have to hand off information between the two. You've got to establish the coordinates. Revit has to understand what the coordinate system is, and the only way you can really do that is to acquire it from a Civil 3D file. And then once you've done that, you can start synchronizing data. You can send a 3D building to Civil. You can get topography from Civil into Revit. And then you can also send everything into InfraWorks to get a big picture. And so that's kind of what this course focused on, was sharing of the data and getting it all set up right. The first thing, which Marissa took care of this slide during the presentation, so I'll let her handle it right now.
Yeah, so as Nick said, the first part of this is acceptance and allowing, us to work together by accepting each other. And the first thing is for civil engineers that are, actually, let me back up. It's telling, we're trying to tell each other how we both work, okay? So for the civil engineers, we need to understand that the buildings are rotated so that they fit on a piece of paper. They don't really care where they are right now. They're just trying to put it on a piece of paper to create construction drawings. So we as civil engineers need to be okay with that. But on the same token, architects, you've got to realize that the world is round and it doesn't revolve around your building, at least not in our world, because we have to work with the stuff that goes outside of the building, and it's in, conjunction with all the other things, and they all need to come together in the right location. So we really need location. And we use sort of grids, and that's the coordinate systems, to locate these items, your building, the roads, the surrounding pipes, things like that. We're mostly using state planes. So for those of you not familiar with this, each state has been broken down into a series of areas that can fit, can sort of be laid out on a flat piece of paper as well as possible. Basically, we have a circular earth. Nick, I think if you hit the next one, it should show the little earth thing that we had. There you go. Excuse me. So if you have this circular earth, it's difficult for us to take like a giant piece of paper and try and wrap it around the earth. It doesn't work. It crinkles. So it's been broken down into these smaller areas, and each smaller area has its own origin. It's got its own coordinate system, and that's how we keep coordinates and keep it as accurate as we can. So next slide there.
Yeah.
Yes.
All right. So the inside Revit, to kind of transition what Marissa said into Revit speak, there's three coordinate systems inside Revit. And this is sort of like the first thing I like to tell people is like a lot of people said there's three origins in Revit. No, I don't know who started that. No, there are not three origins. There are not three origins in Revit. There is really one origin, which you couldn't see until a few years ago unless you linked in a CAD file. Arguably, the project base point's an origin, and I'll get into that. And then you have a survey point, which people said was an origin. It is not an origin. It is a reference point. And then sort of you have three coordinate systems, although really I only like to think that you have two. The first one, which I kind of go and not mention, which is the internal coordinate system. Basically, this is the mathematical grid that all software has to have that does anything, even two-dimensional. In this case, we have the 3 dimensions that you have to have in order to just make things work. Then you have the project coordinate system. This is what sets up, your project north, east, west. By default, all of your views in Revit are set up this way, and there's a reason for that. Out of the box, this is what's important, because until you've talked to somebody, you have no idea where your building is going. I don't care if you've looked at a civil plan and you've read the civil file and you think you know where it goes. You can get close, but until a civil engineer gets involved, and you might be able to get the X and the Y down, but until you get a civil engineer involved, the Z is really tricky. And so it has to be a collaborative effort. And the designers of Revit realized this and said, okay, you know what? We're going to create a system that lets architects put it how they want to. And then the in the coordinate system we're going to make that coordinates it with the real world, the shared coordinates, that's going to be a reference. It's not a real grid. It's just a reference that says, okay, at this project base point lives at this real world coordinate. And that's how it really works. And so that's kind of the way this is set up to show, is that the orange is the project coordinates, the blue is the shared coordinates. And I always say leave the project coordinate or the project base point and the internal origin at the same point, and make it a point that's easily identifiable on your building. There's arguments that can be made to move the project base point away from that, but and then the big thing to know is that internal origin, that's where that 30-mile radius that's not really a radius, that's not really 30 miles limitation comes from. So anyway, all right, we're getting a few questions coming in. I'm going to see. One of the questions was, is there a manual input? I'm guessing that's for the GIS coordinate system, and the answer to that is no. I can't tell you how much I wish there was a way for you to manually enter that inside Revit. Up until Revit 2018, you couldn't even put it in Revit. So someone's asking, do you share coordinates with civil engineer? So the shared coordinates, this is where we start getting into the demonstration, which we don't have time for. But yes, in a perfect world, your shared coordinates inside Revit and inside between all your building files are the same as the one with the civil. What's nice about Revit is actually you can set up several shared coordinates in one Revit file. So if you have to, and I'm not saying this is a good workflow, but if you have to have one set of coordinates for, say, the contractor who did their point cloud in one coordinate system without looking at what coordinate system the drawings were in, you can set up the two coordinate systems, and because it's just a relationship, Revit just switches which one you're looking at. So in a perfect world, everyone's on the same shared coordinates. In the real world, that's the joy of Revit, is it's designed to be able to handle multiple shared real world coordinate systems. So
Nick, I think, did we have, after that demonstration slide, I think there was another one that listed off the steps so that we can at least talk about the steps.
Oh, there we go.
There it is.
Yeah, there we go.
Right there. Mm-hmm.
So it's very similar to the first step. And then, yeah, so the first thing was we all have to accept that
we got to work together.
We got to work together. And in a perfect world, we all have to agree on one coordinate system that works for everybody, whether it's a state plane. If you're outside of the U.S., it could be something else. But I know most of the people here are within the U.S. Do we want to do that poll to find out?
There were some, and I saw someone from Canada.
Yes, and if you are calling from outside of where the survey is actually asking, I know a lot of you have already. I saw a lot of locals. Then please let us know in the chat where you're calling from. I saw some Colorados, both Colorado Springs and Denver, a few Denvers, some Canada, Seattle, Washington. That's awesome.
Yeah, that's pretty great.
So definitely let us know. Let this survey go for a few more minutes, and then we'll also ask you which discipline. Hopefully we have that one in there. So, and let's share the results here. So it looks like a lot of us are local, right? Maryland, Virginia, and North Carolina, pretty evenly split, almost exactly evenly split, but a lot of other states not listed. So we might need to increase this list somehow. It's pretty awesome, you guys. I love the reach we're getting.
I was gonna say we got
Michigan,
a few people out of the U.S. That's awesome.
Yeah,
that is
that's
very,
cool.
very cool. All right. And so let's.
So I'm gonna jump back into just answer these really quick questions. So let's not forget that civil engineers derive the XYZ data from a surveyor. So yeah, once again, we all have to talk.
Yeah, we didn't even put in the part about the civil engineers working with the surveyors. That's its own sort of animal sometimes. And having been on both sides of it, it's definitely an animal sometimes. But to be honest, we agree that we're not that happy with you guys sometimes. But, that's how we sort of bond. And so that is absolutely important. I mean, the surveyors are the ones that are going to establish, where the existing part is and where the site is in the world. And then we are the ones that have to decide where the building is going to go on the site. And then, of course, we hand that. So, basically Nick will hand me a floor plan, or basically a floor outline, and I stick it into my site and rotate it and put it in the right place. And then I'll have to send him coordinates of, whatever his origin was. So he's going to tell me what his origin was, and I send him the coordinates and the elevation of where I think that should be. Then he can take that basically back into Revit, and that's where he can then, that you do have to manually type in, right? Those coordinates have to be manually typed in?
Yes, the way we showed it.
Okay.
You could also use an add-in, free add-in from Autodesk. You need one on both ends. So Civil 3D needs to be able to install it, and Revit needs to have it installed. I think they're both now finally have the same name, called the shared reference point. Essentially what that does is it manually, or you click some points and it fills out a text file, and then in Revit you select that text file and it fills in the data. So we showed it without that add-in because there are some people that can't install add-ins.
Yeah.
And because I know that add-in was shown with another presentation that's on AU. So I was like, well, I want to show another way of doing the same thing.
I'm going to actually show it in a little bit.
Oh, yeah. Well, there you go.
Yeah.
There was Dan Warren had 2 points. One that I love and I don't know how to solve, but is that he sees projects with Project North. So when you start modeling, you model everything skewed as if you were modeling to True North. Don't do that. Bad.
It looks like we have another question. How much easier it becomes to have a shared coordinate system in a campus environment and sharing that with your contractors for that campus?
Before I fully understood this personally is one reason. I used to think you'd have to have a local point that you would use. And that's where moving the project base point away from the internal origin might make sense. Is that you use the internal origin as the local point for a whole campus, and then you have project base points for each building in there. And a lot of time when you get to that kind of setup is you end up with one Revit file that's the site Revit file, and that's the one that's controlling the coordinates for everybody.
I think that's a pretty typical method. So let's actually jump over to Alex, who I'm sure has a lot to say on that. Alex Russo comes to us with Smith Group. He's Associate Civil Engineer with Smith Group, and I work with him directly. Very, very lucky to have civil engineers in-house at Smith Group, I very well say, which is still, to me, very much of a mystery. So I'm very lucky to have Alex in-house to be able to ask him questions. So how are you doing today, Alex?
I'm doing good. Thanks, Dana. Yeah, so a lot of the topics that Nick and Marissa talked about, I was sitting here thinking like, oh yeah, I'll show that. So I know Michael later is going to talk about the shared reference point tool, which definitely is one really effective way to get the shared coordinates from civil engineers out to the Revit models for architecture's MEP structural. But the way that and we've adopted here at Smith Group is to take a Revit model and basically create a site model from it. So we've actually developed our own template for civil engineers and landscape architects to use because we do actually do a little bit of Revit modeling ourselves, so we can kind of more accurately show the site in relationship to the building. So for me, the best way to show anything is always to just do a demo. So we're going to give it a go. Live demo here. Sometimes those work out good. Sometimes they have their own struggles. So we'll see what happens here. So talked about the survey. The surveyors, they're the ones who usually establish, what coordinate system you're going to be on. Most likely it's going to be NAVD 83, which is, a coordinate system set up back in 1983 to kind of get that state plane coordinate system set up. This is a project located in Michigan, and It's just a basic CAD file. The problem that usually happens between Revit and Civil 3D is Civil 3D has its own content that is native to it, and Revit doesn't quite understand it. I'm talking about points and surfaces and then pipe networks. Those are three things that are Civil 3D specific that Revit tends to struggle with. So if you were just to purely link a Civil 3D file from the civil engineer directly into Revit, you're going to get all sorts of warnings. There's going to be a lot of issues with those files. Another thing that isn't great with Revit is the 20-mile radius. So if you linked in that file and there's something hanging out in space, you're going to get a lot of skewing of the visuals when you zoom in and zoom out. And oftentimes you'll know that's an issue when you first link in a CAD file. If it says couldn't be found, it's going to link it center to center. That's bad news. Your file's going to be way off in space and you're going to have some issues in Revit. So always want to be careful with that. So let's talk about the setting up of a file. This one's pretty basic, but there's two ways that you would want to prepare a CAD file for Revit. The first is to run an export. So this is purely in Civil 3D. I know most users are probably Revit users, but I'll just show you what it's like for me on my end. I would come and do an export Civil 3D drawing. It's going to pull up some settings, but basically I just need to tell it where to go. What this export does is, I'm going to go ahead and accept my settings here. So what it's going to do is it's going to delete, or it's going to dumb down all the Civil 3D objects into just plain AutoCAD. So you're going to get rid of all those points. You're going to get rid of the pipe networks and surfaces. It's just going to be dumb AutoCAD line work. And that's what Revit really needs. It doesn't need any of the fancy stuff that you can manipulate in Civil 3D. Once you've done that, most of the time you're going to be good. That is assuming that you don't have things outside of your 20-mile radius, which tends to be an issue sometimes. So the other file that I'm going to be using here today is a layout file. This file I've already coordinated with, since this project's pretty much on that done. I've coordinated with architects and we've already kind of got the building model. They've exported out for me. I was able to locate it on the site, which is probably one of the first steps that you'll ever want to do, is give an export to the civil engineers so they can understand what that building is. And the number one thing I can always recommend, export with grids. You want your grids turned on. The reason being, as a civil engineer, the building footprint exterior looks great, but early on in the project, you've just used a generic wall. And then as you move on, you're going to start adding in brick, and then inevitably that building keeps expanding just a little bit. So having those building edges as a reference line early on is really troublesome because things expand. So grids, that's something that usually never moves. So I always like to use those in locating my model. With this model here, I'm just going to go ahead now and show you the second way to do it, and that's using a W block. That command is just going to take all the objects that I want to select, and I'll just select the objects that I want, except for that. And it's just going to grab just that. What this does is it ensures that it limits that 20-mile radius to just the objects that I've selected. I can go ahead and save this where I want to. So the W block command is great to kind of hone in on a 20-mile radius. Export command is one that you'll want to do to dumb down the AutoCAD objects. Sometimes you need to do both. And oftentimes in Revit, if you get errors, you'll know that you've probably got to go that extra step and do the export and W block. So I'm all done here in Civil 3D. Those are two things that I've done early on, is I've exported the survey, which is what I want to start from for the site model, and then the layout, which I like to bring in so I can locate that building where I've already decided in CAD. I'm going to jump over into Revit 2020. This is what the model will look like. And I have a project started out here that I want to just, I've already done the synchronize, saved it. So this is using our civil template that we have created in Revit. You can just use any generic template. All you really need is just a layout plan and some elevations. So within Revit, what we want to do is open out our layout plan, which I got. It's a working one, so I can just add stuff and don't have to worry about annotations or anything. And I'm going to go to the Insert tab. To link in CAD files, you always want to do link CAD. You don't want to do the import for these. And I'm going to go ahead and find that file. So I've saved it here. I'm going to start with my survey. There's some settings that you'll want to make sure you have set up right away, and that's colors. You can leave it as preserved or you can leave black and white. but this correct lines that are slightly off axis, that's always selected to start. You want to make sure that's unchecked. What that's going to do is, in the civil world, we might be close to north and south, but we're not quite there. Revit buildings, they're like almost always on orthogonal grids. If you got a line that's close, if you left that checked, it's going to force the CAD file to skew. We don't like that at all. And then the inserting, initially you want to bring it in origin to origin. We don't have shared coordinates set up yet, so we're just going to bring that in.
Heather is actually asking if you can show the export again from Civil 3D to AutoCAD. Is there a way to get rid of the 3D topo lines that stay 3D, but everything else flatten? She said she tried to do this the other day, but there's still a bunch of weird things going on with the survey file.
Yeah, so you wanted the survey to be, or the contours to get flattened?
A way for the 3D topo lines to stay 3D, but everything else to be flattened.
Okay. Yeah, I mean, that's honestly what typically could happen with a CAD file is oftentimes the line work, all the line work's drawn at 0 elevation, but the surface elements such as contours, they're going to hover up high. So as long as the surface style is set up in Civil 3D to show your contours, when you export that, the contours will still be shown. They're just going to be polylines at that point. So they'll have an elevation associated with it. When you bring it into Revit, they'll actually have the true elevation, whereas all the line work would be down at elevation 0.
I'm going to interject here because it's one thing that I've really liked about how you kind of disassociate the 3D topography from the Civil 3D link. That way you can control those separately. So like the line work is one thing, and that's at the flat level, and then the 3D is at a separate link, so you can turn things on and off.
Yeah, and we've gone as far in our world as creating 2 files. We've had one that's just line work, and we've had one that's surface elements. That does give you a little bit more control, and I think that might have been a little what Nick was talking about too. All right, so back in Revit, what I got here is now linked in this survey file. What I want to do is I need to move it to put it close to our origin. Now, one thing I want to recommend is when you do this move, always use something that's a known point. Because this is a survey, usually there's a benchmark located on it or a property line. For this one, I have a property boundary edge right here. And that's what I want to set right at my origin point. The reason I do that is that's a known point. I can check it. You can look at the coordinates in Civil 3D, look at the coordinates in Revit, and they're going to be always known. Especially if it's on a benchmark, that's something you can go out in the field and find every single time. So that's a really big key.
Is that something that you would probably coordinate with the team, or would you just decide on your own?
You pretty much decide on your own. Oftentimes there's going to be 2 or 3 benchmarks that are noted on the survey. You just want to find one that's going to be closest to the building. That way, you have a pretty good reference that's close by.
I always in the past hated moving the civils engineering Civil 3D file. Like I just I wanted to leave it where it was, and then that was like where my point was. So I'm really happy that you do that, but I don't have to. But can you talk to a little bit why maybe that's not set up in Civil 3D and why we're doing that in Revit? Is it just because of the translation between the points, I guess?
Yeah, it's the coordinate translation between a shared coordinate system and the project coordinate system. It does need to make a translation in Revit versus Civil 3D. It's just always real world coordinates. When I link in this file here, it was dumb to start. I brought it in origin to origin. It had no data into it. So that's where we need to move it initially. After you set up the shared coordinates, that's when you never want to move the file. It should be reliant upon the shared coordinates then.
And just to be clear, this is typical, like what you're setting up now would be kind of what Nick was referencing to before, kind of that site-specific Revit file that everybody's going to link to establish that.
And really, you could, depending on what you're trying to do, you can actually set the shared coordinates up before you bring the Civil 3D file in. And what that does is rather than manually or auto placing it, you can actually pick auto by shared coordinates. And what that'll do is it'll actually align the 2 coordinate systems between Civil 3D and Revit. And that's how Revit finally learns the true GIS coordinate system. That's the only way that it'll know, hey, it's this NAD 83, whichever state plane it is. So
Yeah, so there's multiple ways to get to this end solution. The key is just doing it early on in your project. You want to make sure you get that set up early. It just makes life a lot easier. Exports coming down from Revit for civil engineers. We can just bring it in on 000. Same thing. You can bring in the updated layout file into Revit later, and it's going to drop in where we want it to. So setting it up early is the biggest key. There's a lot of different ways. I know Michael's going to show another way too. But this site model that we're talking about right now, this is a great use for campus. It's going to have its shared coordinates set up. I can link in 10, 20, 30 architectural models. Probably don't want to go to a bunch, but you can link them in, locate them on the site. If you got a real nice CAD background, you can locate them in, and then everything's on the same shared coordinate system. It's really great for that.
And when you say a known point, do you mean something existing? Like you said that the point that you, I guess that's a property line that you point would be easy to be found, but would maybe like a corner of an existing building be something that you'd want to, like, what are some maybe examples of a point that you would select?
Yeah, worst case scenario, building corner, but not all buildings sometimes last, especially if it's an old one. Those could get moved. And oftentimes too, if you got a survey stake, trying to go up against a building, you're never going to get exactly there because the width of the rod that you're using is always going to be in effect. So benchmarks are the best that you can use. Those are pretty much always going to be used on a survey. It's called out somewhere, or control point. Those are two different things that surveyors always are going to be setting up initially in their survey. That way they can be easily replicated by another surveyor when they're going out there to stake things in the field. So those are the two that you want to look for, control points or benchmarks. Each have record data that you can go back to the surveyor to find. Okay, so I'll jump into kind of getting those coordinates, and then we can probably jump on into Michael. But so right now, just showing these coordinates here, if I click on the project base point or the survey point, they all have 000 set to it. So what I got to do now that I've brought in my model here, or the survey model, is acquire the coordinates. So to do that, you go to the Manage tab, and then there's a coordinates here. That's where you select acquire coordinates. So this is, all I'm doing is, sorry, I went to a little quick, but it had asked to select a link. I click the CAD file and it happens automatically. If I click this point now, there we go. We have a northing and an easting that are set up to match our real world coordinates. You'll note now though that the elevation is at 0. So this is that one thing that Nick had talked about earlier, to make sure you're coordinating with the civil engineer to set up that Z. You can get close, but you're never going to know it exactly until the grading's been done on the civil side. So the second step that you'd want to do to kind of establish that Z for a file like this is jump over into an elevation view. And here I have my building first floor. That's where it was brought in. That's just the template that we have set up. But you can establish that Z. You can do it one or two ways. You can move the building floor up, or you can use another handy tool that Revit's got built in, and that is to relocate the project. So if I went to position, relocate project, I'm just going to select down here, and I know that I set this building at 604. If you do that, it's going to move the entire site up 604 feet. So zooming out, there we go. Now my building first floor is at elevation 604. So if I was to link in the architectural Revit model, which would be my next step in all of this, it's going to come in at the right elevation that I want it to. So I'm going to do 2 quick links, and then we can move on. So I'm going to link in now that layout file that I prepared before. Now that I have a shared coordinate system, I can set this now to by shared coordinates, link it in, and then it's going to be able to drop in correctly. So if you have any updates down the line up from the engineers that you need to show in your Revit backgrounds, you link that in. It does pop up this error sometimes, but you click OK and it drops in where it wants to. I think that's where Nick was talking about that initial input with coordinate systems being for Revit to finally recognize it. Doing it this way, it knows it's there. It just isn't quite sure how to figure it out, but it gets it right in the end. So there we go. And then now I'm just going to turn off my survey so that we're just seeing the layout. The the last step that you'd want to do is bring in your Revit model. So I'm going to go ahead and link that in. And Nick, I see you might want to add on while I'm doing this. You can certainly chime in.
Well, I was going to ask you to go back because there's two things about what you're showing that I'd like to point out to people. One of them is a change that wasn't really well noted in Revit. I think it was 2020. But if you select your project base point, a lot of people are like, oh, if I enter the values here, I can enter it and move it into the right place. When they got rid of pinning and unpinning the project base point, if you enter values into the parameters, it will actually move the project base point away from the internal origin. And that's a little catch that a lot of people don't know about. And you can really get yourself into problems very easily doing that.
So the clip is gone?
Clip is gone. Yeah. You can clip and unclip the shared, the survey point. You cannot clip and unclip the project base point after 2020. And so now if, so you've got the survey point.
Yep.
So you can clip and unclip that, but the project base point, you don't have a clip anymore. And so if you enter the...
Honestly, that makes me more confused.
It does. Well, they did it on a reason, but my issue with it is they got rid of that, but you can still manually type in the values, which moves the project base point away from the internal origin. And, you know, we know that we can't build away from the internal origin because that causes problems. And then the other thing that I like to point out, if you could go back to your elevation,
yep.
These are little nitpicky things that I have with Revit. Go ahead and select one of your levels and go to the type properties of that level. So right here, the elevation base, it says survey point. That's not the survey point. I get this question all
the time.
It's not the survey point. It is your shared coordinates. Now the project base point is sort of based off the project base point location, the height of that. But where it says survey point, it is not based off of where in the z-axis the survey point is. It could care less where the z-axis is the survey point. And I think that's one of the key confusion parts of where people think the survey point's an origin, and it's not. That your survey point, you can move that, and these elevation numbers will not change. So, all
right, we're running a little bit on short on time.
It's
okay. This is a wonderful conversation, and I love it. But before we jump to Michael, we do have a few questions. So Sarah asks, even though your CAD file you refer to as being dumbed down, you can still bring in the coordinates. So you still acquired the coordinates from it.
Yeah, all the actual like horizontal line work is going to be set. It's just getting rid of
like the real life coordinates are still set within the file.
Yeah, all the line work's going to be good. It's stripping the Civil 3D content.
And Heather asks, it looked like before you relocated your project using the position tool, your sea level was set to negative 15 feet. Is that just the way our template, like what?
Yeah, that's just the way our template's set up because our building floor is where I really want the building to come in. So I had that initially set at 0. The step that I do actually next is then after I have that first floor set, I'd bring this down to 0. And then I do all of my modeling off a survey point or the sea level. So in this beautiful model over here, I end up setting all my floors and everything to sea level so I can type in true elevations to get it all set up.
Interesting. Okay. Another question, how critical are import units when importing civil CAD files?
Very, very critical. Yeah. So you want to make sure that you always set that. For us, we're using foot. I know in Canada metric, so you want to make sure you're using the right units going back and forth.
And that's usually when I'm teaching it, that's really the only time that I'm messing with that units function when I'm importing CAD is when I'm using civil files. So always make sure that you're using the right imports. Absolutely. And then can you specify coordinates at a point?
In the Revit model?
Yes, I guess so. Heather,
yeah, I mean, you can annotate if that's what the question was. So you can do a spot coordinate and yeah, you can check it. And there we go. We got actual points. So you can, in your modeling, show those building corners with coordinates.
And would that be the same as entering the data? I feel like
entering the data would be these. I might be getting the question wrong.
Okay. Maybe we'll have Heather jump in later and ask some questions.
Yeah.
Because I love Heather and she obviously brings some wonderful perspective. So
I think what the answer is when you moved your CAD file and then you acquired the coordinates, that's very similar as the same as if you went to manage and specify coordinates at point. Because when you acquired it from the CAD file, it got the coordinates at the internal origin and at the project base point and filled that data in. So specify coordinates at point is just another way of accomplishing the same thing.
Awesome. All right. Well, without further ado, and of course, we will have hopefully a few questions or, time at the end for some questions and some discussion. We'll bring in Michael, and Michael is a support specialist with Autodesk. Hopefully I'm getting his title right. I believe it's designated support specialist at Autodesk. So thank you for joining us today, Michael. How are you?
Good. I know that I only have 12 minutes, so I'll try to get it all in there.
We usually do run long. I will wrap up at 2, but if we run a little long, that's okay.
Okay, cool.
At least from my perspective.
So I guess I'll give a little bit of background for me. I'm a civil engineer, EIT, started off as a support specialist at Autodesk. And I used to get a bunch of questions, a bunch of support tickets asking, all right, why is my Revit model not coming into the right location in civil, and why can I get my civil line work to show up in Revit? And we're really good in our support team. Like the civil folks know their stuff, the Revit stuff know their stuff. They also know Navisworks, but they weren't great at talking to each other. As Marissa and Nick mentioned, we need to talk to each other. So I decided, hey, we have this great tool and our documentation isn't that great. So I had the idea, hey, I'm going to write some information out, write the steps, kind of get down into it and figure out the workflow and how this shared reference point tool actually works. So I think you actually shared the kind of where to get it. So I'm going to be able to skip through some of my PowerPoint. I'm going to put a link in the Zoom group chat. It's the data sets that I'm using. So if anybody wants to try this out on their own, feel free to download it and follow along. So let me start off here with civil. I'm really glad that Alex mentioned the grids. I taught this class at AU 2 years. My first year, I would not rely on a grid and my elevations would come in wrong. So yeah, I have a grid now. And the best way to think about this is you need to be able to select 2 points. Select 2 points in civil that you can then select in Revit. And those 2 points is how the two pieces of, the two softwares are going to interact and talk to each other and kind of handle this exchange. So before I would do this top corner, now I rely on a nice little grid. This is civil. The functionality hasn't changed all that much through the years. So I think we've had the shared reference point tool around since I think 2014. But once you get it installed, you do have to install it in each of the programs. So there's a separate civil installation and a separate Revit one. The tool lives in your toolbox under Subscription Extension Manager, Autodesk Reference Point Tool, and right over here, Export Shared Reference Points for, it's kind of cut off, it's down here. But when you select it, it doesn't seem like it does much. It's just telling you, all right, pick a point. You pick a point. So since I'm using a grid, I'm going to select one of the points on my grid. And then the next little toggle down here is telling you select a point on +y axis quasi-north. Really confusing. I couldn't figure out what it was actually asking me for. I would select a bunch of separate points, and sometimes it doesn't take the information in. Basically, it's just telling you to select another point. The trick here is to make sure that the point is at the right elevation, at the same elevation as your first point. That's why a lot of folks will run into this and instantly drop the tool because it's like, oh, it's not working. Pick the first point. The second point that you're picking has to be at the same elevation. So since it's a grid, it's all flat for me. It's all at elevation 0. I'm going to select any of the other points. I'm going to just pick this one. It's just a habit. I think Nick mentioned it. Basically what the tool does is it writes out this XYZ information and then the rotation for your XY plane. So you will get an XML file that Civil writes out for the location of your line work here. So one of the things to note, I think somebody asked if units are important. Units are extremely important. I actually use meters because the building that I'm using is the Autodesk Research Center in Toronto. So it's a metric coordinate system. So it's in meters. Somebody asked for feet. It will work in feet if your coordinate system is set up for feet. There was one question on there that was very interesting that I wanted to bring to the group. If feet versus US survey feet matters. I don't think so personally, because in the Revit model, the US survey feet, like their model is not big enough that US survey feet will really matter. But I'm getting funny looks from folks, so we can talk about that in a little bit. So meters, I'm going to press OK. It's going to write out an XML file. Let's see. I did BIMxt. I did a copy for a dry run that I did earlier. So BIMxt. File name, my shared reference point. I'm going to save this. And for now, I'm going to leave civil alone. Head over to Revit. So this is our beautiful building. Nice little Revit model here. Going to go over to my floor plan. Again, I'm actually a civil guy, Civil 3D and InfraWorks. So I play around in Revit. I don't really know too much about Revit besides doing enough to get me in danger sometimes. But nice thing here, let's isolate the grid just so I don't select anything that I don't mean to. So I'm going to isolate this category. If zoom would go away, that'd be great. And well, the tool's up here. It's under add-ins. If you go to add-ins, import shared coordinates from XML file. This is the shared reference point tool on the Revit side. So I'm going to click here. What it's going to do is it's going to kind of ask me to do the same thing that I did in the civil side. So select the same 2 points. So I did A1, 109. And then I did this guy down here, the C2Y 301. And now what it's going to ask me for is an XML file. So the XML file that I created previously, this my shared reference points. Click on it. It's going to ask you if you want to create a new shared coordinate called my shared reference point. Click yes. Successfully created. I'm going to end my isolation. Everything looks great so far. Now, this is the confusing part because people think, okay, I'm here, I'm done. There's nothing else that needs to get done. My 2 models are linked. You actually have to go under Manage, Location, and set the site, because what it's going to do is it's going to stay at the same internal, that default site. It's going to create the new My Shared Ref Point site, but it's not actually going to make it current. So when you make it current, now we're actually using that information that we got from our Civil 3D drawing. One of the quick tests that I like to do, by the way, for anybody that noticed, that, oh boy, this is where my Revit IQ is lacking. The project base point went away. Not that it went away, it moved just to have that information, but the project base point is still here. And it kind of filled in this information automatically for us based off of the information that was in that XML. One of the nice checks that I like to do is for the orientation, I like to just set it to true north just to make sure that my building is orienting the way that I want it to. So just click apply and it looks pretty good. You can see that it tilts. I see a lot of times on the support side, I used to at least, if you pick the points in the, instead of picking point 1 and 2, then pick point 2 and 1, it flips and mirrors everything. So that's why I just like to do this little test. So looking good. And from here now, basically you've set it up so you can start to send data back and forth between Revit and Civil 3D. So I'm gonna go to my 3D model. I'm gonna export this. And the reason I'm doing this is because there are some settings that you need to tweak. So DWG export, click over here. The big ones, you want to go to units and coordinates. It will always default to this. It'll default to inches and internal origin. For us, we know that we're in Canada, or supposedly in Canada for this project. So I'm going to go to meters. And for the coordinate base, you want to use shared coordinates. Press OK. Click Next. And I'm going to leave this alone, and it's going to now export my Revit model into a DWG.
I wonder if that could be something you could manipulate with the INI, the unit export or something along those lines, like your background settings.
It's saved with the template.
Yeah.
So if you change it with your template, you can have multiple DWG exports.
Just save it as a style, I suppose.
Yeah, the only issue that the other, I don't want to say issue. The other solution you have is you can also use a Navisworks file, which is a little bit smaller on the AutoCAD side of things, as far as working with it. So, because DWGs and Navisworks files are the only files that you can export from Revit and use shared coordinates. Everything else exports with project coordinates or internal coordinates.
Yep.
And in Revit, Michael, can you show us where the survey point went to? Maybe the zoom extents.
It went really far away. Let's go. Zoom. No, it's not going to be zoom out. Is it?
Yes.
Again, ZE.
So
yeah,
with that,
it's
the
like
survey
way down
point's
here.
going to remain at 0, 0. So that's why it jumps, because it's actually, it's not a jump. It's everything moves except the survey point out in the space.
If you unclip the survey point before you do that, at least when you're specifying coordinates at point, it'll keep the survey point where the project base point is. And I would imagine it would do the same thing here with the method that you're showing, is if you unclip the survey point before you change the systems, the survey point will stay. But the survey point isn't a origin, so it's just a reference point.
So is this point technically too far away? Like when I open up the file, am I going to get the pop-up?
It's not. It's just when you do zoom extents, you're going to have a big
It's going to be way out there. Yeah.
And I think, yes, Joshua, in this scenario, the survey point stayed and everything else moved.
Way out there.
Right, Alex?
No, the internal origin, if he turns the internal origin on, it should be at the project base point.
Revit knowledge. It's not all there.
Hit VV. And then scroll down until you get to site.
Also, we shared in the comments, the internal origin, especially if you're upgrading your templates, upgrading your Revit models, this is now visible everywhere, that internal origin. There are some resources that Autodesk has provided in ways to share that or to turn that off through Dynamo. So before we wrap up with a few final thoughts, thank you so much to our presenters, Nick, Marissa, Alex, Michael, for presenting today. I really hope, I know I have, everybody has benefited from the discussion today. It is recorded. I know this is definitely one that I'm going to have to watch back and slowly maybe like rewind certain portions or what have you. We can find that hopefully within a few days on our LinkedIn group. Alice and Uza has shared the link to that within the chat if you do not have that. And of course, you can just search for the BIMxt network group on LinkedIn. So please feel free to get on there, provide your chat, provide your insight. Thank you for everybody who has done that today within our chat. So any last thoughts, everybody? Alex, Nick, Michael?
There was one question that came out talking about architectural model being done well in advance of civil. That's always the case. It pretty much always is. So it's not a worry. Continue working. In that instance, you would use origin to link all your models around. But then you can always set up the share coordinates afterwards. So using the site model or using that SharePoint tool, both will work at the end.
It
That's
still
actually
goes once
almost
you set it up. Just don't move it. Right?
Yeah, I wouldn't move it unless you absolutely have to. Like suddenly you decide to put the building because you found something underground that you didn't know was there. But yeah, what Alex said is what I was going to say is, if you don't know where your building lives, don't even argue with shared coordinates. Just link everything via internal origin point to start out with. And this kind of matches the way, you were supposed to set things up in CAD, in a CAD environment, that everybody's XYZ origin was in the same place. And so you would link based off of 000. So it's kind of the same concept. And then once you know it, you can just say, hey, this building, this 00 is actually at this real world point. So.
Michael, any final thoughts or comments that you have?
No, this was great because the stuff that I didn't get to cover was covered by everybody else. So this is perfect. Thank you for
I
having
think
me.
that's like one of the things that makes this so confusing, especially for someone who's not a civil engineer, right? Is everybody seems to do it differently. Everybody has their own process of doing it. And then of course, as somebody mentioned, if it's set up after the Revit model, it's like a, then you're really thrown in, or, like Nick was saying, if your building moves, like, oh my gosh, what do I do? Who do I call? One question came in. Assuming the file is the site file the architect is using, how would the MEP engineer acquire coordinates from the file? Does Revit 21 allow files with multiple coordinates to be published from that file?
Yeah, so using the site model, what you do, if you're in BIM 360, it matters or not. If you're on a network, you can just publish out coordinates. You link in MEP, structural, architectural, and you can publish them out directly to each one of those models. Make sure everyone's out of the model before you do the publish. If you're in BIM 360, you have to go the opposite way around. I would have acquired the grids, or actually, sorry, copy monitored the grids into the site model. That way I have something to link into or line up. So in my MEP model, line up or bring in the site model and then acquire from that site model. That's how you do it in BIM 360.
Same way that you would do the architects, right?
Yes.
MEP wouldn't be different.
No, yeah, MEP structural, they'd all be the same. Link it in and then acquire.
The only note for me is the workflow only really works in Civil. So that plugin will only be available for Civil 3D.
Well, thank you all once again. Thank you so much for our panelists who have joined us today. And please, once again, join our LinkedIn group. We will see you next month.